Okay, unlike the last time I was out, this is not a recycled video. This was made especially for you. Yesterday we talked about the rational zero theorem, so today we are looking at irrational zeros. So remember, rational means we can write it as a ratio of two numbers. Irrational means that we cannot. So we are still going to start the same way we would any of the other ones. The directions say to find all zeros and write all answers in simplest form. So in number 1, we have a quartic, and it's 3 terms, so we can treat this like a quadratic to factor it. So since this is x to the 4th, this will be x squared and x squared. And I need 2 numbers that multiply to give me 18 and combine to give me -9. Since this is positive, the signs have to be the same. Since this is negative, they're both negative, so it's going to be -3 and -6. All right? So this is my factored form. I cannot factor it anymore. This is not a difference of squares. This is a perfect square, but this is not. This is a perfect square, but this is not. So this is as much as I can factor it. That is my fully factored form. Then I need to find my zeros. So from this, right, here are my 2 sets of zeros here. So what we do to find the zeros, it's going to be x squared minus 3 equals 0, and x squared minus 6 equals 0. So then x squared equals 3. So I take the square root of both sides, and I'm going to get x equals, what? Square root of 3? Is that it? I'm missing something very important. Plus or minus. You cannot forget the plus or minus. This is x squared equals 6, so I take the square root of both sides, and x is equal to plus or minus the square root of 6. Okay, so here's my fully factored form. It's okay that I wrote the line in it just to separate it. And then my zeros, x is equal to, this is plus or minus the square root of 3, plus or minus the square root of 6. And there we go. All right, so number 2. We have another one that is a quartic, but we can treat it like a quadratic. So this has an a that is not 1, and I do not have a GCF. 4 times 8, 32. You can go ahead and factor this on your own. I'm going to factor this using grouping. So just to kind of walk through that again, but you can just go through and do this on your own, and I won't say anything while I'm doing it. Okay, so when I get to this point here, this is not a difference of squares here, but this is a difference of squares here. So this is x squared minus 8 times 2x plus 1 times 2x minus 1. This is my fully factored form here. Now I have to find my zeros. All right, so I'm going to separate this stuff out. Now we've been finding these zeros without having to show all that work for a long time, so I know that this means that I get x equals -1/2. This means that I get x equals 1/2. Then here, since x squared minus 8 equals 0, then x squared equals 8. So x equals plus or minus the square root of 8, which simplifies down into plus or minus 2 square root of 2. So my x's are plus or minus 1/2 and plus or minus 2 square root of 2. All right, let's jump to number 4. So here I have a cubic, but I have 4 terms, so I can factor this by grouping. So let's factor this by grouping. I'm going to factor out my 3x squared. That leaves me with x minus 5. I can factor out a -4, and that also leaves me with x minus 5. So that means that f of x is equal to 3x squared minus 4 times x minus 5. So obviously this is as little as it can get. This is not a difference of squares, so this is my fully factored form. Then I'm going to split this. I know that this is going to give me x equals 5. It's one of my x's. Here, I'm going to get 3x squared minus 4 equals 0. So 3x squared equals 4. I cannot take the square root of both sides right here. I have to divide by the 3. So I get x squared equals 4/3. So x equals plus or minus the square root of 4/3, the whole thing. Now, not that you would have to write this part, but this is the same thing as plus or minus the square root of 4 over the square root of 3. Those are the same. Again, not saying you have to write that out, but we can take the square root of 4. It's going to give us plus or minus 2 over the square root of 3, but we cannot leave a square root in the denominator. Therefore, you have to rationalize. And when you rationalize, that's going to give you 2 square root of 3 over 3, with the plus or minus. Okay, so there's my other x values. So your zeros here are going to be plus or minus 2 square root of 3 over 3 and 5. And if you need to go back and review rationalizing your denominator, do that. All right, flip this over. We are only going to do number 6. This is similar to, we're doing some of the same things we did yesterday, but then also having to find the irrational parts of this. So we have to start off by listing all of our possible rational real zeros. So that means I'm going to use the constant term and this leading coefficient. And since this is 1, I don't have to make my little fraction. Pretty much my possibles are just the factors of 15. So plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. And this, even though this has 4 terms and I could try and factor by grouping, when you do that, it's not going to work out for you. So that's why we have to do the synthetic substitution. So I'm going to start with 1. Start with 1. My coefficients are 1, negative 5, negative 29, and negative 15. Okay. Then we should be able to run through this pretty quickly. 1, 1, negative 4, negative 4, negative 33, negative 33, negative 48. So that's a big fat no on that 1. So then I try negative 1. Using the same coefficients. 1, negative 5, negative 29, negative 15. 1, negative 6, 6, negative 23, 23, 8. So 1 and negative 1, big fat no. So now move on to, not to 2, because 2 isn't up there, I move on to 3. All right, so for 3, I'm still using 1, negative 5, negative 29, negative 15. Okay. Run through that, bring that 1 down, and that's 3, negative 2, negative 6, negative 35. 3 times a negative 35 is a negative 105, and then this gives me negative 120. So positive 3 is a big fat no also. So now I move on to negative 3. Using the same coefficients. 1, negative 5, negative 29, negative 15. Bring down my 1. Negative 3, negative 8, 9. Oh, not 9. Where am I coming from? Sorry, making stuff up. So negative 8. So then this is positive 24. That makes a whole lot more sense. Negative 5, positive 15, and 0. So finally, we have something that works. Negative 3, which means the factor is x plus 3. All right, so I have f of x equals x plus 3 times 3 terms, which means it's quadratic, x squared minus 8x minus 5. All right, so this is a quadratic, and I can't get 2 numbers that multiply to give me 5 that will combine to give me 8, so I can't factor that. So what do we do with a quadratic when we can't factor it? If it's factorable, then I would get one of these, but none of that's going to work. So your other option is
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, so hopefully that song will be forever embedded in your brain so that you can remember it. So we have factored as much as we can factor. Now we've got to use quadratic formula to help us with the rest. So this is going to give you x equals negative 3. So here, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I get x equals 8 plus or minus the square root of 64, and then negative 4 and negative 5 is going to be a positive 20 all over 2. So that is equal to 8 plus or minus the square root of 84 over 2. So now I got to simplify the square root of 84. So go ahead and figure out what you think that might be. I know that 4 divides into 84. That would leave me with 21, and I can't take anything else out of that. So 8 plus or minus, since I can take the 4 out of the 84, I would take the square root of that. That would be 2 square root of 21 all over 2. And then I can reduce, not because I can just cancel these out, but because I can cancel it out of both. So your x is going to be plus or minus, oh, not plus or minus, sorry about that. It's going to be 4 plus or minus the square root of 21. So here are the two I get from this, and then here's the one I get from this. So your x's in the end are negative 3 and 4 plus or minus the square root of 21. Have to know quadratic formula and how to use it quickly and accurately. All right, so now grab your other sheet of paper, and this is going on page 46. Okay, this stuff just kind of all goes together. So this is Descartes' rule of signs, which helps us narrow things down even more. So René Descartes, he was a French philosopher and mathematician in around 1637. He was helpful in eliminating possible zeros from a lengthy list. So this can be helpful. The Cartesian plane, if you've ever heard of that, that's the x and y coordinate plane that you graph on. He is responsible for that. And some other things, we'll talk about him a little bit more, but that's who René Descartes is. So to understand this rule, we must look at the variations in signs in a polynomial function. When a polynomial function is written in standard form, that means that your exponents go in descending order. A variation in sign occurs when consecutive, okay, and consecutive just means one right after another, coefficients have opposite signs. Right? So it's a variation when consecutive coefficients have opposite signs, so the ones next to each other. So here's the example, and it says, how many variations in signs does this function below have? Okay, so this is a positive 4. From here to here, it goes from positive to negative. So that's one variation. Then we go from negative to positive. That's another one. Then it goes, so this is 1, this is 2. Positive, positive, that's not a variation because it's the same. Then positive, negative, that's another variation. That's the third one. And then negative, negative, it doesn't change. So the answer to that question, there are 3 variations. Right? So we have to be able to figure that out to be able to use his rule here. So Descartes' rule of signs says, given polynomial function f of x written in standard form with real coefficients, the number of positive real zeros is equal to the number of variations in signs or less than that by an even number. Okay? Which means, so it's equal to the number of variations or less than that by an even number. So up here we got 3. So it's 3 or 1. Those are only options because it's this or less than, or then I subtract 2 by an even number. So if it was 7, it could be 7 or 5 or 3 or 1. Then the number of negative real zeros is equal to the number of variations in signs of f of negative x. And again, or less than that by an even number. So with Descartes' rule of signs, Descartes' rule of signs includes repeated zeros. Therefore, a zero with a multiplicity of m is counted as m zeros. So even though we only write it down once, so if I have like x minus 2 quantity squared, so 2 is a 0, but it has a multiplicity of 2, it counts as 2 in this case, is what we're counting. I mean, we'd still only write it once, but it would actually count as 2 of them. So all we are doing here is stating the possible number of positive and negative real zeros. So the positive ones come from f of x, the negative ones come from f of negative x. So let's look at what's happening here. Here's f of x, right? So I start with a negative, then it changes to positive, so that's 1. Positive, positive, so then positive changes to negative, and negative changes to positive. Okay? So for my positive real zeros, my options are 3, because there's 1, 2, 3, or 1, because it's less than that by an even number. So then I have to find for f of negative x. All right, so f of negative x, when you substitute in a negative x, the only way the sign's going to change is if your exponent is odd. Otherwise, if it's even, it just, takes the negative back out of it. But with the odd one, it's going to change the sign. So this is negative 3x to the 4th minus 12x cubed plus 5x squared plus x plus 18. We are substituting in a negative x, so everything with an odd exponent has to change its sign. Then we look. So this is negative, negative. That's fine. Negative changes to positive, 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 right? So my negative real zeros, there would be 1. So let's try number 2. Right, so I have positive to negative, that's a change. Negative to positive, that's a change. Positive to negative, that's a change. Negative to negative, it's the same. Negative to positive, that's another change. So for my positive zeros, I got 1, 2, 3, 4. So it's 4 or less than that by an even number, 2 or 0. Maybe there aren't any. Then I have to do f of negative x. That's equal to, right, so I have to substitute that in. Everything with an odd exponent changes its sign. Negative x to the 5th minus 2x to the 4th minus 3x cubed minus 6x squared plus 4x plus 8. Okay? So I've substituted in my negative x. Now I look at the variations and signs. Negative stays negative, stays negative, stays negative, changes to positive, stays positive. So for negative, it's only 1. I can't get less than that by an even number. So what we are doing here, we came up with a list of numbers, right, yesterday and for the first part of today. And then from that list, because we did plus or minus on all of them, we know how many positive and negatives are possible. So if I already have a negative 0 that I've used, right, and then I don't need to check any more of the negative ones because I can only have one of them anyway. All right. So let's look at number 3. I'm going to, it's positive, stays positive, stays positive. So for my positive zeros, it's 0. There's no variations in signs, so there's no way that there's any positive ones. Then I need to find f of negative x. Everything with an odd exponent changes its sign. So 2x to the fourth minus 21x cubed plus 27. So it's positive, changes to negative, changes back to positive. So for negative, this tells me I have either 2 or 0 real negative zeros, which also tells me I have to have some imaginary ones because I can have up to 4 roots there. Okay, so these numbers do not always add up to give you that exponent. Keep that in mind as well. All right, so I'm going to give you a second. I want you to try number 4. Don't just copy it down. Try it on your own. Okay, so on this one, there's just one change for the positive. So there's just 1. So we know we have 1. And then for the negative, there's no change at all. So even though this has a degree of 4, there's only one possible real zero here. It's positive. And we're talking real zeros, so it could be rational or irrational. It's just the fact that it's real. All right, flip it over. We are going to do number 10. So it says, create a list of all possible rational zeros, then find all real zeros. Use Descartes' rule of signs to help you eliminate possibilities. Okay, so we're doing number 10. So we're going to come up with all of the possibles. So I'm using this and this, just like we've been doing. So that means I could have in the numerator these factors plus or minus 1, plus or minus 2, plus or minus 4. In the denominator, I'd have plus or minus 1, plus or minus 2. So my possibilities would be 1 over 1, which is plus or minus 1. 1 over 2, which is plus or minus 1/2. 2 over 1, which is plus or minus 2. 2 over 2, which is plus or minus 1. I already have that one. Then I put 4 over 1, plus or minus 4. 4 over 2, that's 2. I already have that. So those are my possibilities right here. Okay, this is it. So now I'm also going to look at Descartes' rule of signs. So for my positive, I'm looking at this. So it's positive, 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 positive. So positive real zeros is 0. Then negative, my f of negative x, is equal to, I only change the signs on the odd exponents, so 2x to the fourth minus 15x cubed plus 31x squared minus 20x plus 4. Okay. Then I look at the variations here. Positive to negative, negative to positive, positive to negative, negative to positive. So that's 1, 2, 3, 4. So my negative possibilities are 4, 2, or 0. Okay, so this is going to help me out tremendously, right? When I go in here to start checking these, because I can't factor this, I'm going to have to reduce it using my synthetic substitution. But when I go in there to do that, I have no positive real zeros, so why would I even bother with positive 1? I'm going to start with negative 1. The positives don't mean anything to me now. And you make sure that you don't use this one, that you are using this. My coefficients are 2, 15, 31, 20, and 4. Okay, so then I run through this. This is going to give me 2, negative 2, 13, negative 13. So when you subtract this, so you don't make it too hard, do 31 minus 10, that's 21. Then minus another 3, and you get 18. Then this is negative 18, and 2, and negative 2, and 2. All right, so That means that -1 is not an option. I'm going to skip over that 1/2, so neither one of these work. I'm going to skip over the 1/2 because I'd rather not have to deal with the fraction if I didn't have to right now. And we'll move on to the 2. But I don't need to do +2. I'm going to do -2. Use the same coefficients, 2, 15, 31, 20, and 4. Bring down my 2. And this becomes -4. Then I get 11, -22, 9, -18, 2, -4, and 0. So this is good. I've got it narrowed down a little bit, so let's write this out and maybe I can factor from here. So I know that f of x equals, since this one works, this is, the factor is x plus 2. I get x plus 2 times, this is 1, 2, 3, 4 terms, so it's cubic, it's 2x cubed plus 11x squared plus 9x plus 2. Now, can I simplify, or can I factor this? I mean, it's set up for grouping, but yeah, there's nothing there I can group, right? So I have to keep on trying. So now I will try the 4, right? So I've already done -2. So now I'm going to try -4. I'll do it over here. So I'm going to try -4. And I'm going to use the reduced one. I get to use this because it worked. 2, 11, 9, and 2. So bring my 2 down. This is -8. This is 3, -12, -3, 12, 14. So -4 doesn't work. Okay, I've already taken care of these, and my -4 doesn't work, and I know positive doesn't. So it really, -1/2 has to work. But I still need to check it, because if it doesn't, then something else we did somewhere is totally wrong. So I'm using these same reduced numbers, 2, 11, 9, and 2. So I can bring down the 2. So -1/2 times 2 is -1. And this gives me 10 times -1/2 is a -5. This gives me 4 times a -1/2 is -2. And that's 0. So that one works. Okay? So that means now that I get what I have here. So this is not x plus 1/2 is not my factor. What this means is that x equals, let me do it in a different color. What this is telling me is that x equals -1/2. All right? And these all have to be whole numbers in the end. So in order to get it back to where I would have it, I would have to multiply both sides by 2, and I get 2x equals -1. So 2x plus 1 is the actual factor. So now over here, f of x is equal to, I've got x plus 2. This is the factor that I got out of that -1/2. 2x plus 1, because it said all my coefficients and everything had to be whole numbers. Then this is the reduced version of that. It's going to be a quadratic. And I get 2x squared plus 10x plus 4. And then on this, I can factor. I even have a GCF here, right? So can I factor out my GCF? The GCF here is 2. So I'm going to bring that out in front. 2 times x plus 2 times 2x plus 1 times x squared plus 5x plus 2, not plus 4, plus, 2. All right, so now when I look at this, can I factor this? And the answer to that is no, because I need two numbers to multiply to give me 2 and combine to give me 5, and that's not going to work. So this is as factored as it gets. Then I get my zeros from here. Okay, so I'm going to split these up. Since this 2 does not have a variable on it, it doesn't do anything for me. It's just hanging out there. This tells me x equals -2. This tells me x equals -1/2. I already knew that, right? And then when I substitute this, or I do my, Okay, so as I was saying as the bell rang, I don't remember the exact thing I just said because it's been a few class periods, but we figured out that these were our zeros. So this one here, I cannot factor, so I have to put it into the quadratic formula, which hopefully you can be able to sing in your head by now. So x equals -b plus or minus the square root of b squared minus 4 times a times c. Okay, all over 2 times a. So that's equal to negative 5 plus or minus the square root. 5 squared is 25. These numbers you can barely read over here would give me a negative 8. All over 2. So 25 minus 8 is 17. So this equals negative 5 plus or minus the square root of 17 over 2. All right, so 17 is a prime number, which means that I cannot simplify that at all, and I can't simplify this at all, so that is one of my zeros. Now, had you not factored out this 2 and had you put this in the quadratic formula, you would end up with the same answer. You would have just had to simplify the square root and reduce some things. Okay, so I have my zeros as x equals, so I have negative 2, negative 1/2, and negative 5 plus or minus the square root of 17 over 2. Now, this plus or minus would mean maybe I actually get a positive out of that. Think about what the square root of 17 would be. And if you take the square root of 17, it's going to be a little bit more than 4, but less than 5. And when this is a positive, that's still going to give you a negative 1/2. All right, so which means that this would give me 4 negatives right there. And this is your answer. So although we had 0 positives, there really is 0 positive answers, even though we have that positive, that plus there, because negative 5 plus the square root of 17 is still going to be a negative number. That's what I was trying to get at. Now, tomorrow we're going to review for your test on Thursday. That means tomorrow before school, I must have all makeup work from any absences. Any quiz you have missed needs to have been made up. I will be here tomorrow before school, so make sure that you bring me anything I don't have in my hands yet, and you come and take any quizzes you haven't taken yet, if that applies to you. That does not apply to very many people, but all right, now get to work on your assignment.